Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So this is another video of LLM series in which we will see what is tokenization, which is the input of transformer model, right? Not only transformer model, but of any model. When we are dealing with the text, we require tokenization or tokenizer, right? So let's see what is tokenization. So first of all, whenever we are dealing with the text, right, we cannot pass text directly to the model. First of all, we need to convert it into some numerical form, right? Because in any model, we are doing multiplication or addition kind of operation on matrix, right? So let's suppose I have one text. Let me select here. Yeah. Let's suppose I have one text. My name is Chirag. Okay, simple. So we cannot pass this text directly to the model, but we need to convert it into somehow numerical form, right? So the best way, or you can say easiest way, is we can split this text at space, right? Or in the other word, like we are making each word as a token here. Okay, so let's say this 5 words or 4 words basically we are using as a token. Token is nothing but a smallest unit which we are selecting from the text basically. Okay, so now we have, in this scenario, we have these 4 tokens. Okay, now what we will do, we will assign some id to each word. Okay, so let's suppose my will receive id 1, name will receive 2, age will 3, and Chirag will receive 4. So now basically whenever we will find a word my, okay, so we will replace it with his index or id 1. Whenever I will find word Chirag, it will be replaced as a 4, or it will be represented by number 4, right? And whenever you have a large corpus, okay, let's suppose in only this one sentence we have basically 4 words, and if suggest, let's say you have a corpus in which you have 10,000 words basically, or you can say tokens when we are splitting at a space. So that 10k words or 10k tokens will be considered as a vocabulary size. Okay, it can be a vocab size. So you can say the tokenizer has vocabulary size of 10k. That means it has a 10k tokens. In here it is word. Okay, and this 10k word will be our vocabulary, right? Yeah. So this is how we provide basically a tokenization technique and create the tokens. So now let's see in detail. So here the tokenization is the process of breaking down text into smaller unit. It can be a word, subword, or even character. Depending on the tokenization technique, we will decide whether we will split at a space, at a character, or at a subword. Okay, and tokenization is a crucial pre-processing step. As I mentioned, like we cannot pass directly the text to the model, right? We need to somehow convert it into a numerical form. So one of the technique is tokenization. So there are multiple kind of tokenization or tokenization techniques are there. First we had seen, which is word level tokenization, right? It is nothing but we are just splitting the text at the space, okay, in simple form. So let's suppose we have one sentence, transformer are powerful. So there will be 3 tokens. Each word particularly treated as a token. Now there is another is character level tokenization. In character level tokenization, we are considering each character as a token, right? So if I have word NLP, then NLP word itself has a 3 token, N, L, and P. Whether in word level tokenization, we have each word as a token, right? So if you see, when we are using character level tokenization, right, then we will have our vocabulary size is very small, right? If you consider only A to Z, then it will be a 26, right? Because any word can be represented by a character which is A to Z. If you consider special character another, it can be a 50, right? Or even more than, like you can say like 100 maximum vocab size, right? If you are considering capital and small differently and special character and everything, right? So When you are using word level tokenization, your vocabulary size will be larger, right? Because you need to store each and every word in your vocabulary, right? And in character level, you just have the characters, right? There is another type of tokenization technique which is subword level tokenization. So in word level, we are splitting text at the space, or you can say just at word will consider as a token. In character level, we have character, but subword level tokenization techniques breaks even words also into a smaller subunit. It calls a subword tokenization, right? And this technique is used in the BERT and GPT, right? So we will see how this tokenization technique works, and one of the subword level tokenization technique is byte pair encoding. Okay, and this byte pair encoding technique is used in the model like GPT. And if I talk about the word BERT, BERT use the technique which is called as a word piece tokenizer. So word piece tokenizer is also similar to the byte pair encoding, but slightly different when we are merging the pair. Okay, in this video we will see how byte pair encoding works. Okay, so let's see. Okay, so let's see how it works. So first of all, let's consider we have this 5 sentence as our corpus. Okay, these 5 words we are having as a corpus. So we need to create our vocabulary from this 5 sentence basically, right? So for byte pair encoding, first step is the split each and every character of sentence, right? So you can consider like if for each and every sentence or text we are using character level tokenization here simply, right? So we will get this 5 list. Okay, right? After that we will count a frequency of bigrams. So bigrams is nothing but we are taking each 2 pair, or you can say 2 character here or 2 tokens here as a sequence. Okay, so here if you see, this will be our first pair or first bigram, this will be our second, this can be a third, this will be a fourth, right? And so on. So once we calculate or basically create a pair of character which is bigram, and then we will see how many times they are occurring in our corpus. Okay, so corpus, that means all the sentences or all the data we have, right? So here if you count, we have th 7 times, h is 7 times, it is 7 times, and so on, and ds is only 1 time, right? So we will pick most frequent a pair. Okay, so this is, let's say in our case it's th, right? So we will merge this pair th here, and it will be treated as a individual token, right? So next time whenever we will split, we will consider th as a one token, right? So let's suppose there is a word the. So before, in the first iteration, we were having 3 tokens, right? th and each character basically. But in now next iteration, as we had merged t and h, though we will have only 2 tokens here, right? And then we will consider or calculate again the frequency of each bigram. Okay, so now whenever there is a th, we will combine them, right? So if you see th and e occurring 7 times, a and t occurring 7 times, here also th dot and th 4 times, and so on, right? Again we will pick one pair or bigram which is occurring most of the time, or most occurring bigram, right? So here let's suppose we are selecting this a and t. Then we will merge a and t as at, and we will consider this as a single token, right? And we will continue this process until we will find our vocabulary size. Okay, so whenever you are defining or creating a tokenizer, right, you will specify how much tokens you want in that in that tokenization technique or tokenizer, right, which is called as a vocab size, right? So let's suppose here for this 5 sentence I would require 30 vocabulary size. Okay, or I need only 30 tokens or 30 unique token basically, right? So this one can be a one of the result, right? So let's say th is there, he, at, and rest of them are as a single character as well, and there are like ca, do, og kind of thing you can consider, right? When you are merging this, these are the pairs which are merged, or you can consider it as subword, and these are the characters, right? If you even make it a smaller or larger, it can be a change based on the number of vocabulary size, right? So this is how byte pair encoding works, or you can basically say how you create the byte pair encoding on your training corpus, right? So now let's see what are the advantage and disadvantage, not the disadvantage, but what are the advantages of byte pair encoding basically, right? Over the word level and character level tokenization. So first thing is efficient vocabulary size, right? So byte pair encoding strike a balance between word level and character level tokenization, right? So first of all, let's suppose when we have character level tokenization, it has very less vocabulary size, right? And when we are dealing with word level, it will be large, because for each word we need to create one token, right? But if you see here, we are splitting a very common prefix and suffix like characters, right, into smaller part. So here we should not require each token for each word, right? We can split them into a particular part, right? So that's why it will be a lesser size than word level tokenization, right? So we can say it is like efficient way to create a tokenizer compared to word level and character level. Second thing is handling unseen word. Okay, so it also known as a out of vocabulary word, OOV. So for example, you are training, let's suppose a word level tokenization, right? And you decide 10k as a vocabulary size. So there might be a chance there is a word which is not belong to this 10k vocabulary size or 10k tokens, right? There can be any word. So when you found that word in the testing phase or inference phase, you cannot create a token out of that, right? Here, or you should ignore them, or you should do something or do some process to handle that, right? But when you are dealing with or using a byte pair encoding technique, we know we are dividing a word into smaller unit, right? So there are high chances that your word can be divided in one of the subword which tokenization has, right? Or tokenizer has. Or otherwise, if word is not divided into any subword, at last you have a character level, right? So you can split it into each character. So you don't need to explicitly handle out of vocabulary word or unseen word, right? Third is a reduced vocabulary explosion. It is the same, like a vocabulary size will be efficient, right here. And fourth is a faster training and inference. So you might think how tokenization can make training and inference faster, right? Okay. So when you compare it with the character level tokenization, okay. So first thing is when you tokenize your text, there will be a high sequence length, right? For example, if you want to just uh, tokenize this vocabulary word, okay, only vocabulary word, let's say, then there will be 1 2 3 4 5 6 7 8 9 and 10. So let's say there will be 10 tokens for one word, right? So whenever you are converting whole sentence, there might be a, let's say, 50 tokens, right? When you deal with the word level tokenization, it might be only 10, right? And if you deal with byte pair encoding, it might be, let's say, 10 or less than 10 or more than 10, right? But not even 50, okay? It will be smaller than that. So when we are dealing with byte pair encoding, our sequence length will be smaller. So hence model should process faster at the training. And when we model will predict something, okay, this part is for the input, okay, so sequence length will be smaller. And second part, when you are predicting word, right, one by one, let's say you are predicting, then you need to predict 50 words, okay, or you can say 50 tokens basically, not the word. And when you are using word level or byte pair encoding, you should only predict 10 tokens, right? So predicting 10 tokens will be always faster than predicting a 50 tokens, right? So that's why it makes training and inference faster. Okay. So overall, the byte pair encoding combines the benefit of both word level and character level tokenization, providing an effective balance for handling wide variety of words. As I mentioned, like we can handle out of vocabulary word as well, right? That's why this is useful and used by the state of the art model like GPT. Okay. So this was about the theory of tokenization. Now let's see a practical example how it is working basically. Okay. So there is one library which is tick token. Let me install it here. It contains the implementation of byte pair encoding in an efficient way, so we can utilize and just check how they are working. Okay, what will be the output of tokenizer basically? So if I say here tick token, yeah, this one, this library. So let's install it and utilize. Okay, let me write the code for tick token. Tokenizer will be, let's say, tick token dot get encodings, and we will use, like, let's say GPT-2 encoder. Okay, get encoding. It is not the encoding, it's encoding. Plugin not found. Open a public tick token. We have this version, right? Okay, no issue. Let's see what is there. Okay, let's use GPT-4o. Okay, GPT-4o. Again, plugin is not found. I think we need to install some plugin here. Okay, let's use it as it is. Okay, there might be some issue. Okay, so now let's provide one text. I am providing a text. Let's say tick token is good library, right? And then let's say tokens will be tokenizer dot encode and text. So let's see the tokens. Okay, so if you see, we have the IDs, right? Or you can say indexes for each token, as we had seen here. Like we will assign one index or ID to each tokens, right? So now let's see what this integer represent, right? So let's say for token, in tokens, let's say tokenizer dot decode single bytes, right? Yeah, this token. Now let's print it. Yeah, so if you see here, is good library has individual token, right? Because these words are very common, so they are treated as a single token, right? But if you see tick token is a new word, right? It is not a very common, so they break it down tick token into 3 token basically: T, IKT and OKN, right? So these are the tokens this tokenizer has, right? And if you see, this word is splitted into 3 tokens. That's why it's called as subword when we are dividing one word into smaller subwords, right? So this is how this work basically, right? Yeah, so this is all about this video. If you have any doubt, you can ask in the comment section, we can discuss there. If you like this video, please press the like button and subscribe my channel, and please press the notification icon so you can get the notification whenever I will upload the new video. Thank you.